In session 1, we took a look at the big picture, which says that if we have a population that we want to get data from, we got to get a sample first. That process is called producing data. Then we summarize that sample with exploratory data analysis, and then use probability to make an inference about a population based on the reliability of our sample. In session 2, we took a look at how we organize the data and how we describe a single categorical variable with some graphs. In session 2, we talked about data, individuals, and variables, and how there is two types of variables, categorical and quantitative. And then we took a look at what do we mean by a distribution. A distribution is what values a variable takes, and how often does it take those values. How we summarize a distribution is with a frequency distribution. Frequency distribution lists the values that a variable would take, how often does it take the values with a count, and then what percent of the time it takes the value of that variable. With a single categorical variable, we can describe that data with either a pie chart or a bar chart. Beware of pictographs, because sometimes the area of the pictures can be misleading. This video we're going to talk in detail about session 3, describing the distribution of a single quantitative variable with a histogram. Now remember, we talked about quantitative variables. In this slide, we took a look at there's 5 variables, actually 6, 1, 2, 3, 4, 5, 6 variables. 3 of those are quantitative, age, weight, and height, while the other 3 are categorical. So what we're going to be doing is, how do we describe the distribution of a single quantitative variable like age or weight or height? Remember, we know how to describe a single categorical variable with a frequency distribution and a bar graph. Now we're going to look at how we graphically describe a quantitative variable. Now remember, we can also do a frequency distribution with a quantitative variable, but that's a little bit more tricky. When we do a frequency distribution, we're going to have to put the values of a quantitative variable into what we call bins. And then once we put the values in bins, we can visually see the graph of the frequency distribution through a histogram. That's mainly what we'll be talking about today, is a histogram. We'll also take a look at a stem plot towards the end of the video. So here's a visualization of the frequency distribution of a quantitative variable, and you can see here this is a quantitative variable that looks like they binned the score that different individuals scored on a test. So here we can see that one individual scored between a 40 and a 50, not including 50. That's why we have a parenthesis there, not a bracket. That means it does not include 50. Here it does include 50. That's why it has a bracket. So 2 students scored between a 50 and a 60. 4 students scored between a 60 and a 70, so on and so forth. And it has the relative frequency. So here, instead of a single categorical variable response, we have a bin of different responses. So a range of values between 40 and 50, 50 and 60. Notice that all the bins are of equal width. In other words, that they're all of width, in this case 10. Actually 9, since it doesn't include 50. So once we have our frequency distribution, we can then create our frequency distribution visualization with what we call a histogram. So a histogram looks a lot like a bar graph, but this is not categorical variable. This is a quantitative variable. So a histogram is the visual representation of our frequency distribution. Notice that our bars touch here. That represents the values between 40 and 50. There's one of those between 50 and 60. 2 of those, so we have the count on the y-axis and then the range of scores on the x-axis. So how do we interpret this histogram? We interpret the histogram by looking at the shape of the histogram, the center of the histogram, and the spread of the histogram. That gives us the overall pattern of the histogram. And then we'll take a look at what we call outliers, which are obvious deviations from the pattern. So let's first take a look at the shape of the histogram. When we look at the histogram, and we want to determine what shape the histogram takes, we're going to look really at two things. We're going to look whether or not it's symmetric or skewed, and we're also going to look at its modality, or its peakness. When we talk about symmetry and skewness, a graph can be, or a histogram can either be symmetric, skewed left, or skewed right. When we talk about the modality, that means the number of peaks the distribution has. Let's take a look at some examples of the shape of a distribution. So here we have 3 histograms, and all 3 are symmetric. This is symmetric with 1 peak, that's called unimodal. This is symmetric with 2 peaks, that's called bimodal. And this is symmetric, but it is uniformly, has the same distribution throughout the entire histogram, or approximately the same throughout the entire histogram. That's called uniform symmetric. So we have unimodal symmetric, bimodal symmetric, and uniform symmetric. So that's symmetric histograms. How about the skewed histograms? Also looking at the shape. Remember, the shape could be either symmetric or skewed. In this case, we have something that's skewed right. Notice that the histogram tails off to the right. If it tails off to the right, it's called skewed right. Distribution is skewed right if the histogram has a right tail that is much longer than the left tail. In this case, the left tail is much longer, so that's called skewed left. So we have symmetric histograms that are unimodal, bimodal, or uniform, or skewed histograms that are skewed left or skewed right. So that is how we measure or how we determine the shape. Let's now talk about the center of a histogram. We'll talk about the center of the histogram on session 4.